All right. How's everyone doing? How's everyone doing? All right. Well, thanks everyone for joining. We're going to have some fun today. I know I'm still dropping frames. I know. There's very little I can do. So you'll have to bear with me. Now, that being said, I'm getting fiber, which has the same upload speeds as download speeds, which is going to be fantastic for streaming. Absolutely fantastic for streaming. So I'm very excited about that. If I still have the problems, I have reported that I'm having problems to Twitch. So we'll see if that, I mean, like, they haven't said anything to me. But I know that some other people were having problems as well. So, and it's gotten better. It's gotten better. But yeah. Give everybody just a little bit more time. Today we're going to talk about consensus, and something that I did poorly with the last one was talk about why whatever we are talking about matters. And so that's what I want to cover today. Why consensus matters, what systems use it, why they use it, and how they leverage it to, for their systems. So yeah, that's what we're going to cover today. And then after we're done, that's only going to take like 30 minutes. We're going to have a conversation about it. Then we're going to start setting up and building our own. We're going to build, there's a consensus protocol called Raft, and we're going to spend the week, the next 5 days building Raft. I'm going to learn quite a bit during that. And we're actually going to get to talk about and see how some of the things that we talk about operate. Today, we're just going to set up how actually we're going to try to set it up 2 different ways for how to like debug and work on a distributed system. And I don't mean distributed system as a microservice. A lot of times microservices themselves are not distributed systems. They run in their isolation. That's why you don't store data on them. They're not distributed. They just do their thing and they're stateless. And that's a beautiful aspect of them. Beautiful aspect of them. Keeps them simple. So feel free to ask questions during it, and I'll try to be checking on that. I'd like your questions and your feedback. I plan on making videos next year on these topics, on this stuff, and so I want to take that feedback and wrap it into it. All right. Well. Also, it's good to be back. It's gone for a week. Feels weird to stream. Feels weird. I was so exhausted last night when I got back. My goodness, traveling takes it out of me. All right, let's talk about why consensus is important. We don't have to spend too much time on it, but I do think it's important. That we cover why we're talking on a subject. So a lot of people might not need to worry about consensus. As I was talking about, if you're running a stateless microservice, you probably have never needed it. And that's part of what keeps stateless microservices so simple and so unique. Now, usually you store that state that's not in your microservice in a database that can reach consensus, or in Redis, which can reach consensus. So usually the tools that you rely on to reach consensus are in that backing data store. So Kafka reaches consensus. Redis, your database, whether it's Aerospike or it's MongoDB or Postgres, they reach consensus. Now, I will note here that if you're using SQLite, it's a single node. It doesn't actually reach consensus because there is only a single node. All of this is in distributed systems only, not single computer systems. So that's something interesting to think about. SQLite No consensus. It's easy. Consensus is a hard problem too, as we'll find out. All right. And then let's talk about some. I know I talked about data stores. They're used in more than just data stores, although some would argue that Kubernetes is a data store. If you take a look at this, this is, why consensus is important. You're talking about Kubernetes uses consensus. How does Kubernetes use consensus? Well, if you think about it, usually in Kubernetes, you have a certain number of control plane nodes, usually an odd number, and we'll get into understanding why an odd number is kind of important in the future. But usually an odd number of nodes, so we have 5 here. And then you have another pool of nodes, or it can be different pools of nodes, that can be in the thousands. Let's undo this and make these a different color. Let's make these a different color. We're going to make these green. And these are all going to be red. Red. All right. So these nodes can be in the thousands of nodes. And this is important. But, that's not the button I meant to do at all. All right. But why? Why do you have it's possibly an odd number, but even number is fine here. And why is this doing this? This is what we're going to be talking about. So this is Kubernetes. And what these nodes here do, their main job is to reach consensus. What do they reach consensus about? A lot of things. But mostly about the state of your cluster, these machines that don't have to reach consensus. Their job isn't to reach consensus. Now, that's the example of Kubernetes, but we can also talk about another example. I talked about a database. Now, Kubernetes actually solves this consensus problem by leveraging a database. So we can get into that and we can talk about it if that would be interesting to you. But they actually leverage a database, a distributed log, a distributed ledger that handles that for them. So Kubernetes doesn't handle it directly. These nodes here leverage a distributed ledger. DBs are distributed ledgers. A lot of them are. Obviously not SQLite, but a lot of them are distributed ledgers. And what will happen is you'll have nodes. And now you might be wondering, why do these nodes need to reach consensus? Which is something that we want to cover here. So when you have a database that has these 5 voting nodes, the reason they need to reach consensus is for fault tolerance. And now we'll talk a little bit more about Byzantine fault tolerance and things like that, but it's for fault tolerance. You could lose this node. So if all of your writes came into this node and then you lost this node, even if asynchronously later these were synchronized to these nodes, like this, it wouldn't matter. Because there would be some number of writes that went to this node that weren't yet stored on this. And then if this node gets removed, if for some reason it gets removed from the pool of valid nodes, the machine dies. There's a network partition between this and the rest of the cluster. If that happens, then one of these is going to have to start serving those requests. Now, this could be handled by a load balancer. A lot of people with Kubernetes will put a load balancer group up here. So, a common architecture for a highly available Kubernetes cluster is a load balancing group up here that we can draw like this. We'll make these blue. There we go. And these are load balancers. So these load balancers can distribute the traffic between any one of the control plane nodes. So you're not actually hitting any particular one. And that way, if this one fails, the load balancer can just stop routing traffic to the failed node, and it's fine. And what consensus gives us the ability to do is say, okay, that one can go down. It can fail. Now, there's another aspect of consensus that really actually starts to shine through when you talk about things like blockchain. Blockchain also leverage a type of consensus. Now, they leverage different consensus. I don't like the wording. This is usually considered permissioned consensus, and that what blockchain uses is permissionless. But actually, tomorrow we're going to talk about types of consensus and actually then the subtypes of consensus in there. You know, with permission consensus, you have ones that have like leader election and then leaderless consensus. The raft protocol, what we're doing is a permissioned consensus with a leader. So it's a leader permissioned. So there's a bunch of different ones, but another aspect of consensus, and this is more about the permissionless, or what I'll say is open consensus networks. And I like that terminology a lot better because I made it. The big thing that is with these permissionless ones is I say Byzantine or Byzantine. It's the Byzantine fault tolerance. And basically, we'll talk more about it later, but you have these nodes that are wanting to reach consensus. And when we're talking about the Byzantine fault tolerance, what happens is the way it got this name was it was a conjecture about basically an army circling a city, and they would win if they all attacked, but they would lose if there was two corrupt ones, or the majority corrupt. So in this case, 4 corrupt ones that decide not to attack, and then these people would have their armies decimated in an attack where they didn't all attack. So they needed a way to know if everyone was attacking or not. Effectively. That's kind of, again, a little oversimplification. But what you want to be able to do in this case, where there's 7 nodes, you want to say these 2 can fail and we can still reach consensus, or these 3 can fail and we can still reach consensus. What the permissionless or the open consensus algorithms are also wanting to do is if you insert a few bad actors. So we're going to color these red. You have a few bad actors that want to say the wrong thing. So when in computer systems, generally the consensus we're looking for is understanding what the value of a key is. So in this case, we might the key is going to equal 1, which is a number 1, and the value for that is going to be Merrick, my name. So what we're trying to do is reach consensus where every single machine here understands that the value for the key 1 is Merrick. And we could have these bad actors that say, nah, the value for that is Bob. I know that's really small. That's why I wrote it by my hands. Now you can't read it. But they could say that it is something else. And what this does is if you have the majority, you can say, no, it's actually Merrick. And this is what, fly-by-wire systems do. They have a tiebreaker. So usually there's at least 3 or 5 where there could be that one sensor that's the tiebreaker. Yes. Dezo. Absolutely. So that is what if you joined at the beginning, I talked about. There's effectively 2 different types of consensus. So there's the permissionless. Let me write this down. There we go. Permissionless. And that's, we're going to zoom in here just a little bit. Permissionless. And then there is the permissioned consensus. So I think it's, sometimes people think that this is only a blockchain thing, but it's not. So blockchain, let's write some examples of this, of permissionless algorithms for consensus. This would be your proof of work, your proof of stake, your we'll get into these tomorrow more as we talk about types of consensus, but you'll talk about your distributed proof of stake. There's a bunch in here. There's also a proof of time, it's not called proof of time, it's proof of something, but it's about elapsed time. And these are permissionless. Then down here, you have the permissioned ones. And this is your Paxos is pretty famous. But also Raft. Raft is the one that we're going to be implementing over the next 5 days on stream. Proof of stake. Different type of stake. Well, you don't have to pull your stakes out. You can leave your meat behind. Different type of it's more like a proof of ownership. Medium rare. All right, so Paxos and Raft are probably the most famous ones, but there are other consensus algorithms for permission. And basically, I like to think of this as untrusted versus trusted. So this is, if you like try to look it up, this, I try to use the terminology that makes sense, or I try to use the terminology that a textbook is going to, even though the terminology sucks. Just because if you're going to go look it up. But I have a better way for you to think about it. Permissioned is known actors. And permissionless is unknown actors. And this will make more sense as we go on. Unknown actors. So think of it as in Bitcoin. They want anyone to be a miner. And when you're mining, you're actually validating the things that go into that ledger. And so basically, you want this to be valid for unknown people. You don't know everybody that's going to validate. The same with a proof of stake. You don't know at the beginning everybody that's going to be a validator. Anybody that has a stake can validate if they like. Whereas with Paxos and Raft, everybody has to be known beforehand. When you form the cluster of computers that's going to do this, everybody has to be a part of that from the start. And so these are, known actors versus, so I'll sometimes say known versus unknown algorithms. And they vary quite rapidly, and the problems they have to solve are actually quite different as well, from Paxos and Raft to your proof of work, proof of stake, those type of things. So yeah, the academic terminology is permissionless and permissioned. But a lot of times you'll hear me talk about them as unknown and known actors. But I have some slides, or not some slides, I have some drawings for you guys tomorrow about these. We're going to be talking about these, as well as, some subcategories inside of these, of the different types of ones, whether they're leaderless or leaderful, and those types of things. Today, really what I wanted to stress is that we need consensus. These systems, whether you've just done microservices or a single monolithic thing that's not distributed, both microservices and monoliths don't have this problem. And the reason is a monolith sits on one machine. Monolith sits on one machine on this node. And a microservice doesn't hold state. So a microservice is on multiple machines, but they themselves never have to worry about consensus. The consensus is handled on the backing, the backing consensus system, whatever one you've picked. So a lot of times people don't understand why they would need consensus. And really it's these backing systems that you have to. So let's talk about systems that reach consensus that you might use even today. So let's talk about that really quickly. Kafka. Kafka has a consensus algorithm. They used to use Zookeeper to do it. They now do it without Zookeeper. That was originally the thing that they used to reach consensus. Kubernetes. When you Kubernetes apply, there is a backing system that reaches consensus on what is the latest deployment. And when a deployment updates, it has to go through that consensus algorithm and written to a distributed ledger. That way, this is your high availability. So basically, anything that's highly available that runs on multiple machines has to reach consensus. And again, it could be lazy consensus, which isn't as strong and isn't as consistent. There's a lot of different ways to look at consensus. And that's what we're going to be talking about a lot more tomorrow. So databases. Now, again, Kafka and Kubernetes are databases, whether you want to look at them that way or not. They are. You store data in them. Now, they're unique in how they store data, what data they store, and whatnot, but they are databases. You're storing data in them. They do stuff with that data, specifically do stuff, and they're specifically designed. But databases. So any distributed database, that's probably a good point here, distributed databases. Again, SQLite doesn't have to reach consensus. So these are things. These are the things that require consensus. Now you might be wondering why I'm talking so much about this. Well, we're doing a database thing, and we keep talking about things. And one of the next things that we need to do for the null database is be distributed. We need to be distributed. Right now, the null database just literally puts things in one location, one spot. It's on one server. If that server fails, if that hard disk fails, all your data is lost. It's not fault tolerant at all. And you can't spin up separate copies. They don't talk to each other. So what consensus does is gives us a means to talk to each other and make sure that that data is actually stored across each node. Now, it's a lot harder than it sounds to actually reach this consensus, because when you have these three nodes, basically, you need to know that the put request that was put into this node was distributed across all the other nodes before it's actually a valid record. And if this node rejects it for whatever reason, let's say the communication failed between it, you also have to reject this as not saved and roll it back. Or you can retry it too. You can retry it. And again, this goes down into leader or leaderless. All right. That's why we need consensus. Do you guys want to get into making a distributed consensus algorithm? Specifically raft? Are we ready for that? Tomorrow we're going to go into types of consensus. On Monday, we're going to talk about issues that happen during consensus. Sadly, on Monday, I have a meeting that's going to pop up in the middle that I just can't avoid, even though I'm off. I have to go to that meeting. So we're going to have two parts. We're going to have two separate parts. That's how it's going to be on Monday. On day 4, on Tuesday, we're going to talk about raft specifically. I know that each day we're going to be working on Raft, but we're going to actually step through the Raft protocol and talk about some of the trade-offs that it made. One of the trade-offs Raft makes is that it tries to be very easy as a consensus. We can talk a little bit on that day about Paxos and some of the differences. Paxos is very confusing. You need a degree in advanced physics and a PhD in Paxos to understand how it reaches consensus. Raft isn't necessarily considered to be as efficient though, because it was designed to be easy. So yeah. Anyways, yeah. And then day 5, we're going to try to put everything together. We're going to rehash everything that we've talked about. Why is it needed? And we're going to dig a little bit more into alternates there. I know that we'll spend a whole day on Raft. And with each one of these, except for the day on Raft, we're going to talk about some of the other consensus algorithms. On day 5, we're going to explore a little bit more of the other ones in more depth. So we're going to explore proof of work, proof of stake, but we're also going to explore also some lazy consensus algorithms that are in the permissioned or the known actors, and explore how they take a different approach to it. Consensi. All right. Let's see if my computer's done updating. Oh, it's looking for a password. This should be fast. It could make the stream a little... I was gone for a week. Literally gone. So I didn't update. I know. And then I had an appointment this morning, so I started it updating as soon as I got home. Not my fault. Did you all have a good week? All right, so to do this, we're going to do it 2 ways today. I actually don't know which way I like better. We're going to try to do it 2 ways. Obviously, we're on one machine. And we could take like the really old, what my grandfather used to program, and basically do it on some VMs. We could do some VMs, but we're not going to do this because this sucks. And we'd have to maintain a bunch of VMs because basically to test a distributed system, there's no way to actually test Raft except by having multiple of the thing. So we could do multiple VMs like this, and where we're developing here. But I think this would suck. So we're going to use containers, but there's 2 ways we could use containers that I think will be really nice. And I want to do both because I feel like the one way is going to be better, but I don't know. I don't know for certain. So this will be a little bit of an experiment. These are the new ways. In for new. All right. So obviously these are going to be containers. We're just going to do C. We're just going to do C. But what we're going to do on attempt 1 is use Docker Compose. I have a feeling this is going to be the easy way. I have a feeling this is going to be the easiest way. And I think it will be a really cool way to test distributed systems like this. Because basically each one of these, it's a permissioned one. It has to be a known host. Docker Compose is going to let us make each one of these a known host. So I think that will be good. The other way that we're going to try, and I have a feeling that I'm going to like this because I know these tools better than I know Docker Compose. But I have a feeling like this is actually not the right way to do this. Is we're going to use Tilt and Kubernetes. Just looking at this, I'm pretty sure this is bad because you just added to the stack. We're going to be running Kind and Tilt and it's probably not the right way to do it, but we're going to try it both ways. Cool, we're all up to date. We're going to try it both ways, and we're going to see. With Docker Compose, I think that we can watch the different folders and rebuild automatically because that's one of the things that I want to do. And I know that Tilt provides this for me, where basically like it can redeploy my service with a new container. And I think Docker Compose can do this as well. I don't know if it's going to be able to handle basically we're going to build 3 of the same thing, but they have to be deployed separately. I assume it can. I haven't leveraged it that way. So this is what we're going to see. Yeah. How do I display the system? Oh, you mean like this stuff up here, like my CPU at 1%ish, how much disk space I'm not leveraging, and my memory, and the audio is not working. Is this what you're talking about up here? Processor, also, thanks for joining in. One thing to note for all of you out there watching, my Twitch alerts are down right now because I didn't have enough time. I did not have enough time to get those up and running because I have a whole new network, as we discussed a week and a half ago. Hopefully tonight I'll have the time to set those up so that Twitch alerts will be working. So this is just part of i3. This is i3 up here. We can look at my i3 configuration. Let's see. This is config i3. So this is my i3. I don't remember where. It's pretty far down, actually. Let's see. Resize. Here's my bar. And then I'm just levering i3 blocks for this up here. That does the status stuff. You can actually write this out of a bash script if you like, because basically it just runs this command every second. You can run i3 blocks, and it takes the stuff and dumps it into the toolbar. So really, really simple. But we can look at my i3 blocks config there. And these are literally just the different sections that i3, like this is just. And this is literally just telling it the command to run to get the CPU info. I need to go through and update this some. But yeah, hopefully our AI-powered Twitch alerts will be back online. For those of you on YouTube, I haven't gotten YouTube into the system yet. We can do that next year. It's on next year's goals. All right, let's set this up. I think what we're going to do is do it actually in the null DB. I don't know if it's going to be the next lesson though. So I got to think about the branch. I'm just going to put it on a consensus branch. Because it's going to take us a little while. These 5 days, I don't even know that we get all of Raft made. I don't know that we're going to. Null DB. Let's get this added. My bad. Did any of you guys get to see the video that I made for indexes? Was that pretty clear? It needed a little bit more time on the editing. I'm not gonna lie. There's like animations I could have made, but it was getting long enough that I hadn't made a video. I didn't have time to make more animations, unfortunately, is what it turned out to be. We'll just not put the episode in this branch. We'll rename it in a little bit. And we'll do our consensus in here. Let me update the... Let me update the titles of the stream. Making Raft. Making Raft in Rust. Making Raft Lite. L-I-G-H-T. Raft Lite. In Rust. That's the wrong type of light. I'm such an idiot. 1 second, let me update the titles to not, like, visible light. Oh my gosh. All right. Yeah, it's a skill issue. Mostly an English language skill issue, but it's a skill issue. I get it. All right. Why does Twitch keep telling me to share the love in chat? Share what love? Literally telling me to share the love in chat. I don't know. It's like the 3rd time it's told me. I'm not sure. Chat keeps telling me to share the love. All right, we're on here. So let's start with the Docker Compose. I don't know that I have Docker Compose. I believe it's a separate install from Docker Engine. So let's install that. I'm guessing Arch bundles it. Looking good. Let's do it. And then I have tilt and like kind. We'll just do a kind cluster. Yeah, we already have a kind cluster running. So those are the 2 ways. I want to see, like, I feel like I don't know. I think the compose way is going to be the way to do it. Yeah, I feel like this is going to be the way to test something like this. Just, all right. I just want I can write the file. I just want like the base file. I just want to copy one that's already half. I want one that's half written already. I want one that's, do they have like a half use compose watch? This is what I want. I want half written. I want one that's written that I can just, here we go. All right, perfect. All right, yeah, this should be good. Do we want to, we're going to actually work inside the folder database, I think is the right way to do this. Probably wrong. And then we want to compose.yaml. All right. So this is where I don't know off the top. We basically need to have 2 services or 3 services, but they're all the same. So we're going to say this is going to be node 1. And node, actually, you know what? Let's actually make this at least close first. All right, so here's our builds. So I just want to see a Rust one. Docker compose Rust. Here we go. There's the front end. I don't want to care about the front end. We're back-end engineers here. All right, back-end. Love it. This is... They don't have to tell it that it's Rust. It's going to build it. How does it know how to build it? I thought I'd have to give it a command. I guess the context is never mind. That makes sense because it just builds the Docker file. Never mind. It makes sense. It gives it the context, which has a Docker file. Got it. Never mind. That makes complete sense. I was not thinking. My bad. So we just need the... Wait. Why the target? Okay. See, like, I still think that this is going to be easier. I just generally use tilt with Kubernetes. So this was using an action. Interesting. This uses an action instead of just a context. See, I do want to use watch because like that would be equivalent to what tilt is doing. It will watch where you're watching. Oh, so the actions are okay. So this is going to build a new container. Yeah, we'll need rebuild. We'll need rebuild. We won't be doing watch. There's not like a hot reload for this. Since we're going to be doing it in Rust, it will just need to be a rebuild. And as far as paths go, it's just going to be here. Right, we're sitting here in this file. So yeah, it's just going to be here. Actually, 1 second. Okay, that's what sorry, I was just path should be this. Is that all we need? I think it probably is. We don't need a command. We're just going to build the container so that the container's default runs it, right? We might want to do a command actually though, because we're going to need each one to connect as a specific, because this is a known actors. So if we're going back to this, this is a known actor, a permissioned. So basically there's going to be at start time a set of known nodes. And so we're going to have to basically pass in what node it is. And it's going to have to present itself as that node. So we'll leave the command in here. This is probably going to be like, right now we run the database by just running the database, but we'll put in a command like node. Yeah. I don't know. We'll figure this out later, but yeah, like node 1. This will be node 1. The other one will be node 2. Okay, this looks good. We'll just take this, put that there. Oh, we don't need all of that. We just need that. So and this would be node 3. This is not 0 indexed. All right. And then this would be passing in node 2 and node 3. We probably need to pass in their IP addresses, but we'll find out. All right, that's written. Now we need to make a Docker file to build all of these things. Can I type this without looking at a reference? We'll find out. From... I'm hoping there's just a Rust. Oh, there we go. Copy. Beautiful. Thank you. Do we want a release build? No. No, we don't. It's just going to slow us down. The application would be running faster, but the build will take longer. And there's no reason to take a longer build. This is just us testing. In theory, this you would if this was your Docker file, but we're just testing stuff out. All right, so cargo build. And then really, do we have anything? I think this is it. We're not going to do a multi-stage build. Are we? No, yeah, we could. I want to see what this is going to do. Oh, snap. Oh, snap. Copilot got better. This isn't right though, right? This is wrong. Rust Docker is not the name of it. That's fine. What is it called? It's called the null DB. Null DB. I don't know what it's called. By default, if you don't give it a name, what does it build it as? I don't know. Let's test that out. Let's move this onto the right screen. And then here we can open up. Now these are actually on the wrong screens. I usually put the code I'm editing on 2. You know, just old man. Can't take me out of my norm. Feels weird. Okay, so cargo build. Well. Oh, this is not in... This is not in my code. It's always a relief when it's not in your code. Also not a relief because that makes the problem harder to solve. But it's a relief. It's a relief. All right. Let's see. Do we just need to update? Oh, we might have, weird. I don't remember updating any of these, but we might just need to update one of them. So, which one is it? In Rust, we can actually go and, list the dependency tree. So let's go ahead and do that. It is cargo not dependency. Tree. There's tree in the word. Is it just tree here? It is just tree here. Okay, there we go. This is in clap. All right. So in clap 4.8 or 4.18. So what clap are, oh, wait. Yeah, clap 4.18. Let's see what clap has. Rust clap. Four 4.411. So let's just update that and see if that fixes. Fixes that problem. We'll see. Okay, so it built. Ignore the warnings, please. Those are fine. Those are fine. Oh gosh, it is. Let's fix that. I don't like that. The name is disk log. That's not true. It's the null DB. All right. So now our Docker file will be more correct. Null DB, right? Yeah. Perfect. Okay. Up. Now, in theory, One thing we haven't done is enabled the use of the database to start up with a command. I'm not too worried about that. But right now it is going to start with one. It's going to get this passed to it. Actually, is this the full command or is this overriding the command? I think it's going to override it. So let's do this. We want the compose. Null db. Do we need to quote this? Let's single quote it. Let's single quote it. Let's see. I need to get better about navigation. That didn't feel good. I tried to use find and then like next. And now I can do like CIW, which that feels good. That feels good. But the navigation down there didn't feel great. Didn't feel great at all. All right, so then we can do Docker compose up. It's going to build the container, which is probably going to destroy my stream. Good luck to you guys. Is it gonna build it 3 times? Is it that dumb? If it builds the like, oh, this has the wrong command for node 1. For node 1, that's the wrong command. Wait. Cargo build failed. Failed to select a version for the requirement of clap version 4.4.11. Didn't we just build this? Cargo build? Well. Yeah, look, we're running it. And it's the null DB. It's got our updates. It's got our updates. All right, first. This should be null DB. And the thing is, where it's failing here, I mean, this is what we just changed to the latest version. Oh, look at this. This is absolute garbage. This is garbage. Look at it. It's building the Docker here, and it's building the Docker file here, and it's building. So it's going to build one from each. So this is actually a point to tilt. Tilt would not build this Docker file more than once. I mean, this is not a big deal because it's only going to cache the rust once. So, I mean, like, it's not a, like, huge deal. So, node 3 is the only one that got to cargo run. I don't see that. Yeah. Let's just try Docker Compose up again. Was it just a glitch in the matrix? Did it take this long last time? I don't remember. I think I was talking to you guys. I got super sidetracked. Maybe I looked at my phone. It failed again. So it took this long. All right. Well, this is interesting. Let's look at it. We upped our... So one of the things that you could run into is if one of these depend on clap, but I wouldn't expect this to be different in the container than it is now. The other thing that I could think of is possibly the version of Rust that we're running locally and the version of Rust, like if it, I guess if it was a really old version of Rust, right? Because this is clap 4.4.11. We could go to 4.10, but that wasn't in their candidates. 3.2. 3.2 is forever old. It's forever old. Let's go to crates.io. Over 1 year ago. All right, now there has to be something that we're screwing up in this container file because it works fine outside of it. So let's look at the container. All right, we don't do anything. You know what I'm going to do though is just remove this. That should get us the latest Rust. I'm wondering if that was an autocomplete from, oh, I got Copilot working in, no, I got Clippy. That's Clippy or Copilot. I don't remember. It's one of them. I think it's Copilot. I think that's Copilot. Copilot suggested that one. Let's see if there's a good recommendation. Rust build contain. I think I have always just done from Rust. Yeah, just from Rust. And, you know, to hurt your eyes, just flip back and forth between these two. A little bit like, surprise! This is taking way longer. Hopefully. Oh, it's going to run cargo build on every single one of them. Ah, okay. So this is definitely a container. That's a weird container problem because I would have expected this Rust version. To be current, right? Why wouldn't it be current? Oh. Do I just need to do... Let's actually just tag it out. We want 1.74 Buster. I would have expected this to be that, but what was that? I forgot what it was. The tag is 1. Let's just try 1.74. So this is going to let us, the goal is basically allow us to write some code and see it changing. I did this a long time ago when I was writing a clustering algorithm. Clustering is a little different than, a lot of people actually get clustering and consensus different, confused. But I do like the swim algorithm. I think that you have to do like a highly modified swim, not just raw swim, but I do like the swim algorithm. Oh my goodness, it's going to do it for every single node. Wait. Oh, cool. This actually worked. Well, I mean, not entirely worked. It worked. Soft worked. It made them, and it didn't run cargo build on every single one of them, which let's see how it did that. So it ran cargo build here. I guess it just kind of knew. It's weird because like it started to build them all and then it stopped for some reason. Like once this one actually had a completed image, it was good. Now this is weird. libc. I shouldn't have to bundle glibc, right? You know what? Let's not do this. Let's watch this. Which again, no reason to have a build container at all. Does compose up not rebuild it, the container? It appears no. That's weird. I would expect it to know that there's changes. That's not at all what I would expect from Docker Compose. Do I need to say Docker watch? Even up, like Docker Compose up, this should rebuild like the stuff that's here, right? Since I told it. Okay, this is rebuilding at least. Cool. Okay, that fixed it. I was just mix and matching my base OS versions there. Okay, cool. Okay, so this is not too bad, and this is a pretty small config file. Honestly, probably smaller than Tilt will be. So this is fairly nice, and we can pretty easily like add our command here. So like node name, you know, whatever we want to throw in there as our command. So the thing is, yeah, I guess, yeah, we're going to have a system that does this pretty quickly and easily for us. All right. We can do tilt. And then the other thing is we're going to do all of our communication with proto buffers. So we got to set up proto buffers as well. So let's do that. So let's do, let's tilt file. And do we just want to copy? We want to copy. Let's see. We'll do Eddington. We're gonna yank this. We're gonna throw that in here, and then we can quit this. That's all we needed. Why did I get highlighting on this one? Not this one. That annoys me. Oh well. All right. So what we need to do is, for this, we're going to have to do it a little bit more Kubernetes-esque, because basically we're going to have a deployment file, and then for each one of them, a Kubernetes deployment file, and then we're going to have a Docker build for the service. So this is just going to be the null.db here. And then this is going to be just the root directory right here. And then maybe we'll just put this under Kate's and node 1. Node 2. Node 3. I think that's we'll also have to set up their communication. Actually, I don't know how that's going to be handled in Compose. I'm sure that it will be handled, but we'll tackle that as we do it. Do we want these? We're going to have each one of these exposed. Basically, we'll have to handle each one of these as a stateful set, because each one of these needs to, it's not about disk. Well, in theory, the replication of the log would be on disk. Per raft spec, it's going to be. We're not going to worry about that right now. Actually, they'll all be addressable anyways through Kate's DNS. So we'll just do that. They'll just reference each other directly. So it'll be fine. It'll be fine. We can just delete all of this stuff, right? Docker build. Yep. Delete. All right. Cool. So this will build the container, and then this will deploy 3 different deployments, 1 for each. And this is where we'll set the command. Okay, so then we need to, let's see. indicate node 1.yaml. Node 2.yaml. And node 3.yaml. Let's do this from the Kubernetes command line. Let's do it like pros. So we're going to cd indicates. And you know what? We created all these files for absolutely no reason. Cool. All right, we deleted all the files we created. Feels good sometimes. All right, so let's create these this way. We will do, it's kubectl. I'm just doing K. Create deployment. We'll need the deployment name, which is going to be null db1. Yeah, that's fine. This is a weird way to do it. I was going to say a deployment usually runs multiple of the same thing. This is where deployment's really weird, and it feels like a stateful set thing, but I feel like this is where I think tilts is the wrong answer. I do think that Docker Compose, this is the clean way to do it. All right, so then replicas. What else do we need? I think that's it, right? Yeah. I'm an idiot. So we want this, and then we want to do o YAML, and then dry run equals client, and then we want to pipe this to node 1.yaml. Beautiful. Node 1.yaml. All right. And we're running the null DB. And here we could do, the command. We can set the command here. Not worried about setting the command right now. We'll just leave it with the default entry point. And then all we have to really do is this, right? To do the second one. Yeah. The entry command will have to change. Cool. So now we have all those. And we could, in theory, do tilt up. We'll see if it works. Very rarely do I type all this stuff out and it works on the first try. Obviously, yeah, we'll see. Tilt up. No tilt. Oh, I'm inside the Kates. It's like, what? Well, it didn't work the first time. Like I said, very rarely works the first time I try. Especially since I kind of just hand did some of it. I guess I didn't hand do too much. Okay, cool. Runtime error. What? Oh. Error pulling null DB. I screwed it up. I told you guys. I told you I would screw it up. So the reason it was complaining there is because basically tilt will override what's ever in these files to point towards your local registry. And if you screw it up and tell it that it's a different name than the image name, it can't override it with the name because because you can also deploy like real images, not ones that you've just overridden. So my bad. Sorry, this can also make my stream a little choppy. Once I get my 2 gig fiber though, ooh, the AT&T salesperson was trying to sell me on 5 gig fiber. And I was like, you know what? As much as I like overdoing it, I've been on crappy, 100 megs down and 10 megs up. I think the 2 gigs down and 2 gigs up will be enough of an upgrade. I don't think I really need the 5 gigs, but thank you. Maybe if the null cloud explodes. All right, cool. Gen 0 is in progress. All of these are going to say Gen 0 is in progress because all of them are going to just be right. There is no interconnectivity. None. Okay, cool. So now, man, we're actually doing this faster. I thought people would have questions about what I have covered. I guess not. All right, let's talk protobuffers. Rust protobuffers. Last time I tried Prost did not work very well. Why does TensorFlow has something? What was the one that I used? It wasn't any of these. It wasn't any of these. Prost was rougher to use than the other one that I used, which is not any of these. So let's see. Is it Prost or Prost? I always call it Prost, but I don't know, maybe Prost. Let's see, there's this one. These aren't the ones I've been using. Oh, you know what? We'll try ChatGPT. Oh, I got accepted into ChatGPT 4. We can try some code with it. It's not overwhelmingly. It is nicer. It is actually nicer. Best protobuf libs for Rust. You're a moron. Okay, that didn't help at all. Are you just going to tell me to Google it? Best Rust proto buff libs. You know what I want to see? We did do 0 MQ in Legion, didn't we? Whose idea was that? Whose idea was it to use Legion? It's a terrible idea. But Legion did still have to use protocol buffers to talk to the container runtime. So let's see where that is. Not the workspace. I wanted Legion's cargo. Here we go. Let's see. Oh, you know what? I actually got it out of Legion because it was in the plugins. Oh, that's right. That's right. Because this was in the Docker plugin. This was a delicious thing that we did here. Right? Ballard. What does it use? Build kit. Is that it? Let's see. Oh, they have code gen proto here. Okay, let's look at that. They use Prost. So is this Prost, or we have Rust proto buffers? We have this and this. I feel bad for this guy. A new maintainer. It seems like there's contributors. Does he not want to maintain it? Let's look at which one it seems easier to do. So this I actually really like if it does it the way that we used in Legion, which was where basically on build of the cargo, it built out your stuff. So cargo build also built out the generated stuff. It's pretty slick. Makes it easy to generate rest code from proto files as part of cargo build. Yeah, this is actually a pretty cool system. I like it. Part of me wonders if it's a little too magical, and I know it's not magical because it actually builds the code that you can then check in, and that's all great and dandy, but like, yeah. We have Protoc, right? Yeah, we do. We do. Yep. Absolutely. Okay. Let's start adding this stuff. This should just be a build dependency. Yeah. So this is actually one, like, if you guys don't, it's very good to have build dependencies. Delete. Very good to have build dependencies. And basically what this is doing, if you guys don't know in Rust, is it removes it. It's not built into the final product. So you're saying on build, I need these things. And so Prost build is going to build the protobuffer files, but those are going to be valid Rust files when they're done. So there's no reason to there's no reason to have it as a compiled dependency. So anyways, it's just for building. It's just nice. It's nice. Okay, so it was, wait, what version was this? 12. .3. I don't know what Prost version we're going to use. I'm assuming it's somewhere around, 12.3. Okay, cool. They don't have to be versioned the same, but all right. Let's see. We're going to make a folder for this. So let's do this. We'll do proto, and then we'll name this as message. Let's see. Albert Turning. Thank you so much for the follow. I mean it. Unfortunately for you, we did just purposefully break down my Twitch alerts. And so you don't get an AI generated message right now because it's offline. Tell you what though, the next time you're on, let me know that this happened, and you can unfollow and follow and get your own one. And I would actually encourage you to do it because we save it in a database. In the future, you should be able to see your name as a follower with your story. You get a personalized story just for you. We use generative AI to generate that for you. We built the system on stream, so we actually need to update the system too. So we'll be doing that on stream sometime. So thanks for the follow, and definitely get your custom generated message just for you the next time that you're on and watching. let's see. We want... we want to delete this, and we're going to call this null db. I'm not entirely sure that I know what we want here. I'm just trying to set it up. I don't think I can do lowercase message. Message is maybe a bad. So we need a general construct for doing their leader election and their voting. So let's call this actually vote. We're going to call it vote. Actually, we're going to call it raft. That's what it is. It's our raft protocol. And this will be, our first message will be vote, how they vote. Oh, you know what? We're doing this and we're making proto buffers, and that's all good. But you know what maybe we want? Did we just want to do gRPC? Okay, now this makes me want to... I think probably GRC with tonic is maybe... I'm thinking, like, I'm sitting here writing this and I'm like, oh, we should, like, make the gRPC stuff here. That's going to be the easiest way, because what we're wanting to do is build the raft consensus, and we want to make the communication as painless as possible. So we're just going to use tonic. No. I'm sorry if you're thinking this was the game Raft. We're doing something a little bit more serious. Now, over the next 5 days, we have talked about consensus. And today was part 1. Why do computer systems need to reach consensus? So tomorrow we're going to talk more about the types of consensus. Here you can see we covered it very briefly this morning. There's permissionless and permissioned. I also like to call it unknown and known actors. This is the permissionless or unknown actors is your blockchain type of consensus, whereas the permissioned actors are more of your Paxos and Raft algorithms. So Raft is actually an algorithm to reach consensus. Raft is notoriously used in Kubernetes, and it was actually used in Kafka as well. I'm not actually familiar with the Zookeeper lists, but in Zookeeper used Raft. It's also used in distributed databases. So etcd is another example of Raft, whereas something like MongoDB uses Paxos. No. MongoDB, I don't know what I have to look up what MongoDB uses. Aerospike, the distributed Aerospike data uses a Paxos-like algorithm to reach consensus. And we've been working on this database to learn distributed systems. And so over the next 5 days, we're learning about this. So I start each day at 12 noon and we cover a topic. So today's topic was, why do we need consensus? We talked about microservices and how most people don't need to think about reaching consensus because the state was carried in their database or in Kubernetes or whatnot. We talked about a little bit about what it was as a high level. Tomorrow, we're talking about types of consensus. Day 3, we're talking about issues that arise with consensus. Day 4, we're going to cover the entire Raft spec, the Raft consensus the Raft consensus algorithm spec. And day 5, we're going to cover other, we're going to tie it all together, everything that we learned, plus cover other consensus algorithms like proof of work, proof of stake. I keep wanting to say the D is for distributed proof of stake, but it's not distributed proof of stake. It is I'll think of it in just a second. And then this is a proof of time. It's actually like a proof of elapsed time. There's a bunch of different types of, and even in known or permissioned consensus algorithms, there's different ones even in like Paxos and Raft, and how they do it, whether it is a leader or a leaderless algorithm. So we're going to be covering those on day 5. After the half-hour or hour lesson where you can ask questions, we'll talk about it. We're actually going to build a raft algorithm, or raft lite. It's going to be like raft lite, because we're not going to hit all the requirements. I'm not a super programmer. You'd have to be a super programmer, and I've never actually built Raft from the ground up, even though I know how it does its voting and stuff. I've never actually implemented it. So we're just going to have some fun trying to implement Raft from the ground up. So no, wasn't using gRPC for a game. And like, we could chat about it like in real life if you want to use gRPC, or really for like a database, you could use your own wire protocol that might be more efficient for you. This is for educational purposes, and so like for me, gRPC is just going to be the fastest to just build some messages that send between some processes. I don't really, how they actually put the message on the wire, I don't really care. Our goal is to try to build the Raft consensus algorithm, and gRPC is just probably the easiest. I think, because like if you try to do JSON and the parsing of all the JSON and stuff, I don't think it's quite as easy. And then if you're talking about, I don't know. So like if you want to talk about really efficient, so I have a project called Legion, which is hard to explain exactly what Legion would do, but it actually used a message. Let's see, we can go to Legion. So it actually used ZMQ to do its communication if you're wanting like an actual message thing, because all these other things are like on top of the stack pretty far, and you can actually dig down if you don't need that. So if you're trying to do, you don't need the full stack always. Now, the full stack makes it easy, and we're doing easy. A really high performance database usually does its own message protocol, wire protocol, because you can be faster that way. And the thing is, it's not meant for consumers. When you're doing when Raft is talking to itself, so Raft is basically going to do a bunch of rounds of voting. So you're going to have these nodes that are going to vote, and you have a bunch of them. We have 3 here, and there's going to be these times when these nodes vote. And the thing is, we don't need the whole stack, because it's not for external consumers. So you can encode these however you like and put them on the wire however you like, because you're sending them directly to a known node, a known actor. And so there's no need for the whole stack, because you can be very optimized that way, if you like. So again, I'm not saying that if I was making, I'd have to think about it. I don't know if I was making Raft for real, whether I was use gRPC or not. For educational purposes, it keeps it really, really simple. Yeah. The higher performance that you want, the more you peel back standard stuff. So I guess that's generally how things go, is like you have standards that make it easy. You have this stack of standards, and it makes everything easy. It just makes everything easy. And then you have like, well, if you don't need 3/4 of the standard, you can kind of roll your own. And it makes life more painful because like the standards handle things for you, and that's awesome. But it's like, yeah, you can cut away a lot of it if you're really looking for performance, which a lot of these distributed systems do try to be very performant. It's why, like, so right now, if we look at the null database and you look at how we write in just plain text, but no database actually writes in plain text. Not one is just going to write plain text to a file because it's not efficient. But as an educational key piece, it's really great because people can see what's getting written to the database and see the values and things like that. So we're using just a standard format, but if you look at any one database out there, you have your like BSON, which is binary JSON effectively, that MongoDB uses. You have Aerospike, which has a proprietary data format that they use. You look at Cat, a PostgreSQL, a Postgres database file. You're not going to be able to read anything off of it because it's just a proprietary format. I mean, it's not proprietary in the sense that it's just one designed specifically for them to leverage. And Plody, that's perfectly fine. Plain text has a debugging value. Plain text does have a debugging value, 100%. It's fantastic to sit and debug, and that's okay. So this is why I'm doing this series this week, Implody, is that if people want to learn, I'm just sharing the knowledge that I have. That's what I do here. And then we also find the edges of my knowledge where it fails, and then we learn together. So I share a little bit, and then we learn together a little bit, and we learn through a little bit of my pain. So I'm always finding something that I don't know, and we're moving on, and then we learn it. So yeah. There's one thing to like know a topic conceptually, and then there's another one to like actually go and do it. This week we're going to do raft because our database so far is only on a single machine and it needs to be distributed. But I have never actually fully implemented raft, so this is going to be painful. Join me this week as we suffer with pain and suffering. My pain and suffering. You can have enjoyment for sure. So yeah. Today, we're just setting up. We covered why we need consensus in databases. That's what we did earlier today. And now we're just kind of setting it up. So we kind of got this thing set up where, actually, I can show you the drawing. Yeah, I can show you. So we kind of got this, since it's a distributed system, we actually need to test it. We need like 3 nodes running. And so in the old way, we would have done this with VMs. I think this is the way we're going to go with, but we've done it 2 different ways. And we set this up today where basically we have this compose file and, it builds the same image and runs it 3 different ways. But, this is the node 3, node 2, node 1. Pretty cool. And then the other way is leveraging a thing called tilt, which I use with Kubernetes all the time. And it's doing roughly the same thing in a little different way. The tilt way is not as good, I don't think, unless if you're standard with Kubernetes. I do a lot of Kubernetes stuff, so like this felt natural to me, but I think that it has more overhead. So the nice thing about this is we can do compose up, and basically what will happen is if we do compose watch, it's actually going to start the things. So it's building the files, and then it's going to run them. And then basically, if we make an update to the code, it will rebuild them. So we don't have to sit here and like redeploy and everything. We can have 3 nodes working on consensus all together. And so it's a pretty cool, it's a pretty cool, system. Tilt will do the same thing. Your background is in level graphics, game engine development. Oh, that's super cool. I feel like at some point on this channel, we will build like a simple graphics pipeline, just to learn myself because I don't know it very well. But yeah, I don't know games at all. I'm not cool like that. Have you made a game? Or just work on the game engines? I mean, I say just work. I didn't mean it to sound like that. Did not mean it to sound like that. Oh, you work on the graph? Oh, that's super cool. What game engines, if you're allowed to say? You'll have to teach us a thing or two about graphics. I find graphic processing pipelines to be super cool. Oh, cool. So you're using Direct 3D or 3D Direct, or I'm on Linux. I know what this is called. DirectX. DirectX, yeah. That's like the Windows. The D3 is like the Windows pipeline, the D3, D12. Correct me, I'm probably wrong. That is one thing that I excel at. Okay, yeah. The D3, D12 is Windows. You also know Vulkan. That is what I would probably start using when I go to try to learn it. That's, you know what? So obviously I'm running Linux, but that would be the statement that I would say is that Windows for graphics, I understand why games are very much support Windows first. Every single thing that I see, it's like, oh yeah, that's way easier on Windows stuff. What version of Tonic are we going to use? Ten point two. We don't care about TLS. Not doing that today. I've heard a lot of really good things about Vulkan. Again, this is not my area of expertise, and I haven't used Vulkan. I've heard a lot of good things about Vulkan. At some point, we will have to at least just play around with Vulkan a little bit. Oh, Vulkan has a really good API? That's awesome. Very verbose. Oh. Hey, you know what? That's better than the other way around. We have to implement the server and client. Ugh. I don't need this, though. What I want to look is at their build. So a lot of the times they'll have like a build.r. Yeah. This is. All right, this is what we need. So in Rust, basically for your build, Implody, thank you so much for your follow. I have to tell you, the next time I'm streaming, you should unfollow and refollow me. And the reason being is generally we have, I self-host the null cloud here. And while the null cloud's running, we built this live on stream, our own AI-powered Twitch alerts. And they're pretty awesome because they make a random story about you joining the party. They're pretty funny, too, because they make up information about the person following that it has no idea about. Absolutely zero idea. And they can be kind of funny. We save that in a database, and hopefully that will go onto the website. So I do encourage you. I'm sorry they're down today. They're down on purpose. The servers I can hold in my hand. Tomorrow, hopefully, they're up and running. So you can get your custom personalized follow message. I say personalized like it doesn't just make crap up about you, but it does literally just make crap up about you. Oh. And it says it completely with a straight face. Yeah. So the build.rs is really cool because basically if you can write Rust, you can make a build.rs and run code that runs before like cargo build. So when you run cargo build, it will run this code first. So what they're doing here is actually generating the gRPC stuff first and then compiling your code. But you can do it with a bunch of other stuff too. This is just a gRPC thing you've got to. So let's do build.rs. Dude, I hate seeing projects with make, because when I see that, I see a language that doesn't have the build tools necessary. You know, it's like my argument with Bazel. Bazel's like a really cool build system, but I've never gotten into it because every time I have to use Bazel, I'm like, gross. The language should do this. Like the language tools should provide this for me. I want to be an expert at Go and Rust. I don't want to be an expert at Go, Rust, and Make, or CMake, or Bazel, or, you know, whatever build system it is. I think this is one thing that the Rust community does fairly well. Yes, I understand. I understand what CMake is. I have, at work, we have projects with CMake. I understand. I even mean make, though. Like, make is a level of pain that I don't think projects should need if your tooling is good. Every build system is a pain in C++. I think it's something they should solve. Look, in C++ 2023, I think they've solved a lot of the outstanding issues of like writing safe C++. They need to do two things. They need to do two things, in my opinion. Three things. They have three things that they need to solve. Oh, that was garbage. They have three things that they need to solve. First, they need to have a strict compile that will act much like Rust's and basically fail if it sees memory validity errors. So basically, if you're not using shared pointers and unique pointers more aptly, maybe don't use shared pointers either. But basically a very strict compile that says, no, you have to use all the memory safe stuff. It wouldn't be as good as Rust because it doesn't have the there's still some problems with that, but I think you should be able to turn that on where you can't use the legacy pointers without like unsafe blocks or something. I'm not quite sure. That's one. Build system. This is not 1973 anymore. It needs an officially supported build systems with module support. It needs this. 2000%. I'm going to say strict compile plus more type, more memory safety. The third thing that it needs. Thread safety. It needs a better threading system. C++ 20 modules is not... I tried them, and, you know, maybe I just need to use them a little bit more. It didn't feel great. I haven't written C++ for like 7 years now. And so maybe that's part of the problem, but I tried it and it didn't feel great. Maybe it's a skill issue. I'll chalk it up to a skill issue, but it did not feel great. I think that they should break legacy support. I feel like I think that if you're running in strict mode or something, you cannot have legacy support. That's fine. So like make some stuff that doesn't work with legacy. So make a build system that doesn't work with legacy. And if you need legacy turned on, it works crappily like it does. You know? I think that's fine. I do think that, yeah, I think that C++ should break legacy. I think it should break it entirely, but I also would understand if it was like a flag where you could turn legacy support on and things wouldn't work as well. You know, like, but, you know, you can at least turn legacy support on. It's a massive anchor at this point. I actually like... I like a lot about Rust. I don't know, like, if we got Rust or C++ to have a memory thread and build system like Rust, what would be my favorite language at that point? And at this point, I'd have to say it would be a toss-up. It would be hard for me to pick. There are things about C++ that I like. I know that people are going to hate me, but I love pure virtual functions and like how Rust does or how C++ does interfaces. It makes such intuitive sense to me where you can have a pure virtual class effectively. That makes a ton of sense to me. Maybe that's bad. Maybe I need to look inward at myself. I don't know. It makes sense to me though. I like Rust with its push towards composition, but Rust is kind of composition only. I think I probably only use composition, but I feel like having the option maybe isn't a bad thing. All right, let's walk through this and understand this a little bit. Implodey, so true. So working on a database, one of the hardest things, and I didn't do this work, I'm not that smart, but one of the hardest things to support ARM was basic assumptions of how the processor worked so that we didn't have to lock. Yeah, like we basically said we can guarantee this is safe by how the processor operates, and thus we don't have to lock. Supporting ARM, the processor didn't give the same guarantees, the architecture didn't, and broke those parts of it. So porting to ARM was like super difficult because of those types of things that if you actually care, you can make the assumptions on. And locking is expensive if you're talking about a super fast database. I'm kind of glad I didn't have to do that, although I kind of wish that I did have to do that part because, like, it'd be a fun learning experience. But I learned enough from people complaining about it. So I think what I like in a language here is basically C++ is the Wild West, and Rust and Go is the too restrictive. I think Rust does a pretty good job. So like, and then Rust, I actually think does a pretty good job. So basically, Rust makes letting you pick a little bit difficult. It's really prescriptive in the general, which I like because basically a new user that goes and tries, they're going to have to use a channel to talk between threads, or they're just going to use async await, which is also fairly hard to screw up. You can screw it up. Or if you decide to do, actual system level threads, it doesn't force you, but it almost forces you into using message passing, kind of like Go does. And so Rust is pretty good. Now, I would have to say, if you really want that like very, very optimized threading stuff, I haven't tried with Rust, so I don't know if it's possible. I think it's possible, but I think that would be really painful. I think you would have to use stuff that's like not a well-beaten path. Whereas C++ relatively easily lets you optimize your threading really well, but it's kind of just the Wild West. Like, whether you're a beginner or not, you have to optimize your threading. And then Go is rough. I hate Go's threading. A lot of people will talk about threading in Go being so easy, and it is. The problem is that's the only type of threading they have, and that sucks. If you don't believe me, let me show you something. If you don't believe me, every single container, whether it's a Docker container, an OCI container, or whatnot, uses runc to configure the namespaces and everything. Runc. They use runc. Everybody uses runc. This powers every container run in Linux, which is every container. I want to pull you here. See this 12% C? See this 12% C? Why is it not all in Go? Why is it not all in Go? It has this 12.8% in C because Go cannot guarantee that the thread that you sent to the Linux kernel is the same thread that it will return on. Cannot guarantee you that. Period. So basically, they have to have a C thing that runs beside it that can guarantee threading. Now, if you don't need this, it's fine. Go's fine. But if you actually care about your threads and want to do anything like a database, you can't use Go. Can't use Go. So I do like Go threads when you're just talking about like, oh yeah, it's kind of just like message passing and that's all you can do. That's great. But you can't guarantee that a function will start and end on the same thread. Go will usurp it and put it on a different thread if it feels like it. And that causes problems. That causes problems. So let me tell you. So anyways, people think I'm full of garbage when I complain about Go threads because they're like, oh, it's so amazing. It's so easy. And I'm like, yeah, it is easy. And in general, that's amazing. And I just wish that they had one way to get out of it, like one way to step out and say, yeah, this is a little too much. All right, so I'm trying to understand what they're doing here. All right, so path from environment outdoor. I try not to complain about stuff until I have at least, okay, unless if it's, yeah, and unless if I have like at least found some valid argument. So this is loading it's telling to compile this file. And that's good. So this should generate the code. Yes, Implodey, having the ability is the thing that I find important. With Go, you don't have an ability to break outside of the box. I don't care if Go wanted to say that this was the way to do it, and to break out of the box, you had to do these extra things. You had to put this compiler flag in when you're compiling, or else it will complain, and you have to, do all this other stuff, and it's at your own risk. That wouldn't bother me at all. The fact is you can't with Go, which then is a problem. And it is a problem for what you're saying with 100% saturation. So like a database, they want that ability to have that, to be able to do those things. I haven't done a whole lot of assembly. I think I'll have to do it on stream some because I want to learn it a little bit better. I know assembly. I have written some stuff in assembly, but not enough recently. And I think that everybody should learn it a little bit so that you know how the CPU you're using actually works. All right, so this is the proto file that they're using. Do they need the Java stuff in here? I don't know. So this is compiling the proto. And it looks like they're giving a list of strings here. Dude, shaders, it's rough. Yeah. More power to you. All right, so what is this doing? Type attribute point. Does it even have a point in here? Ah, okay. It does have a message point, but it also has a message rectangle and feature and route notice. Add additional attribute to matched messages, enums, and one-off. Do you stream any of that? Do you stream Implodey? Well, not right now, but I'm saying, are you streaming your shader stuff? I'll. Oh, okay, okay. I thought you were saying like not right now, and I was like, I kind of didn't expect you to have a conversation with me while streaming. I don't watch other streamers. I'm not good enough. Seems like too much work. Okay, so this is just compiling the different files. That seems good. So it's calling configure again here. Oh, I see what's happening. Okay, so these are actually just different samples. For the echo, it's just using this to compile. It's not doing anything specific. These are demonstrations. I get it. So what we're going to do, I think, is try to do just as simple as possible. We're going to do this right here. And we're going to remove this. Oh, sweet. So employee, make sure to share them with my community. Absolutely, make a thing like that. That's a great thing to post. And as long as you don't post stuff, I don't have restrictions on that. I love for people to. This is meant to be educational here. So if people are helping other people learn, it's a great place to. It's a great place for people to share that stuff. I also don't need this. We're going to delete all of this. This now looks too easy. We'll see. Now we have ours in just proto, and what did we call it? It's just message. Oh, did we want... Oh, cool. That sounds awesome. Hey, 1 second. I'm going to have to work on your name. 1 second. I'm going to look at it for just a second. Grampington. Thanks. Thank you, and welcome. Welcome to the chat. So the next 5 days, we are covering consensus, software consensus, not the raft game. I'm not a fast reader, so there's like streamers who like have way more people that are just like going with the names, and I'm like, Greppington. Okay, I got it. Sounds very British. I'm just gonna make that up. It's probably not British. Don't hate me for it. Do I need this? I'm gonna do this. You know what? No, we're gonna not do this for the time being. We're going to see if we can make this work without it. Oh, you know what, though? I don't have a gRPC implementation. Let's do that first. We need just a service. So yeah, we're talking about consensus and how I've structured this, and it will happen tomorrow as well. Is we talk a little bit about a topic, and then as we go on, we're creating. We're going to try to create the raft consensus protocol, which maybe I should put that in the title. So people don't think I'm making a game, because I'm not. I have both the Rust game and the raft game in my title. It's a little confusing. Let's see, service. We'll call this raft. Yeah, it's just the raft service. And our first one is going to be to vote. So this is going to be a vote request and a let's see, it's going to be a vote reply. And we'll do the same here. This will be a vote request and a vote reply. We don't have a... Tomorrow we'll work a little bit on actually what we need to send to do voting and stuff, but for right now, we're just... Basically, today we're spending some time setting the project up so that we can actually program on it more. Oh, Grumpington, I'm so sorry. I'm so sorry. We're talking about why you need consensus in software engineering, what it is, and how to do it. And I thought the best way was I can do my little educational talks, but then I was like, what better way than to actually build it on stream? It's going to be painful. So if you like to see somebody suffer on stream, yeah, you can follow, you can watch me suffer on stream. But if you... Yeah, I'm not cool enough to make a video game, to be honest. I probably am not smart enough as well. You do like sorry? Thank you. you'll stay. You came for the game, but you'll stick around for the suffering. That's fair. That's fair. Okay, so right. You'll stick around to see me suffer a little. They had these, which is a little weird. The Java outer class and stuff. I'm going to leave them because what I'm worried is like they actually use these in the generating of the protobuffer message. So right now we're trying to get protobuffers working and gRPC working in a Rust project so that we can pass messages between our distributed systems. So we're building a distributed system and we've got this part working. And so now to test a distributed system, we're using this basically. We also set this up, but we'll probably just use the Docker Compose, where it basically hot reloads these containers as we make changes to them. So as we're building our consensus algorithm, and to test a consensus algorithm, you really have to be running 3. We're going to set it up this way. And so we got that all set up earlier today, which was fantastic. And now we're just basically getting it set up to build protobuffer messages and talk to each other with them. Which I haven't done gRPC in Rust. We're just using Tonic. Pretty good project. All right. So an ad is starting soon, and when the ad starts, I'm going to go up and get another drink. So I'll be back. It might be like 5 minutes. Let's see. What did we do? Okay, yeah, let's do cargo build. This build should build our build file. And we should see the output from it. It actually worked. I kind of thought it wasn't going to. Debug. Where would it build it, though? I thought that this would have built the protobuffer messages out. All right. You'll have to include the generated code. I know I have to include the generated code, but where did it put the generated code? Actually, let's see. Did it put it in proto? Yeah, there should be like a message.rs somewhere, right? I don't see it. I don't see it. Yeah, that's where I thought I would have thought. We can look in the proto file. Like there is no dot, no message.rs, which is kind of where I thought it was going to, which makes me kind of think this didn't work. Makes me kind of think that our build didn't build. I didn't think I needed to call anything for Rust to run the build.rs. I thought it was always going to run the build.rs. That's what I was looking through the cargo if I needed to like tell it to do the build.rs. I can bump the version. I have it at 2018. I can do 2024. It's not even 2024 yet. My goodness. I just cleaned it. We only have a few warnings. Actually, and like the worst one of these is not in my code, unfortunately. All right, let's see if we can't find it now. Yeah, there's no proto. The only thing that we have is this message.proto. And I was looking because like in fuzzy find and whatnot, we don't actually see the output. That's where I was looking at like target, if it was like actually just being but it doesn't look like it's being dropped out here either. This is the binary. That's the wrong binary, right? That's the wrong binary. It has dislog, but we changed the name to nulldb. It shouldn't be dislog anymore. It was dislog, and then we just You know what's worse is this is working in the container that we built today. The nulldb part. What have I done wrong here? Let's just remove target. Wait a second. Is it not building? We don't have any errors. Can't have errors if you never build. I am building. I'm trying to. Also, these are not warnings from my code. Well, this one is. This one is. I can fix that one. Oh, let's see. Virtual workspace to fall into Resolver 1, despite one or more workspaces members being on edition 2020. Okay. I don't think that matters. Where is this building to, though? Shouldn't be building here because I was in the database. So interesting. The weird thing is, watch this. Cargo run. So the database is running. So like I know that it's working. I just don't know where it's actually dropping its and then if you look at the Docker file, like we do cargo build and then we copy from target debug because this is just a test container, and we run the null db. So I just don't know where everything went because we don't have a target. And why is it not building one? That makes sense. The build.rgn file, but nothing is using them, so it won't actually be part of the debug or release build. Oh, okay. I thought that it would drop them right in here, like right beside them, and not copy them out. Like the thing that gets in the target debug is just the generated, like the actual compiled. I thought it would actually generate them here, but maybe they're not. So you're saying I need to actually include them. I could also just make a syntax error here. Let's do this. Watch this. Oh my goodness. No semicolon. Okay, so my feeling was correct. You know what we're going to do? Cargo fix bin null db. This isn't running. This isn't running. The build.rs isn't running. I mean, this is wrong, right? Oh, I guess because this was the only thing, having a semicolon wouldn't have been... Let me redo this. Okay, so it is running. Because it was the only thing. It was actually returning it, which I don't know what this is. Returns a builder. Was fine for main. Okay, so it is running? So now we just need to include the code? But where is it getting built to? Like, it has to be generating code, and it's not generating it anywhere. Are you saying that it just deletes it afterwards, and it's not just keeping the code around? I guess that's maybe fair. Maybe that's fair. Okay, so let's go and actually depend on it. Let's go depend on it. I'm going to look at how they do their using. Where's the hello world? Keep it simple. So they're doing this. Okay. All right, let me try this. Where do we want to do it? I guess we're probably going to make a new place for communications. Do we want a new place for communications? Let's see. We're just gonna do it in a new file here. We'll play around with it over here. Naming is hard. Okay, yep, that's not the name it's gonna be. We'll fix it. We'll fix it. We'll fix it. All right. So now ours is not called Hello World. This should error on us, except. Let's actually include this. Okay. So it did error on us. Let's see. This is called... I don't remember what message is. And then... Okay, so this is good. Oh, it's looking for the RS file. Ah, and this is also where it is. Cool. Awesome. But this does help me because we do have it is message.proto. Okay. I'm wondering if this is the thing that they're looking for. This right here, or maybe it's this package. Probably the package. We're just gonna call this raft. And I'll update these to be raft as well. They had these in their example. I don't know if these are important. I think we'll implement I think we'll implement all of the raft communication, so like the voting and all of that in the same file to keep it simple. Thanks, Grumpington. I think you're right. We're kind of working. I was just missing a step. So this is gonna fail unless if we actually generate this now, because can we not include this until we have built first? All right, let's do this. Okay, let's These should be wrong. Those are wrong anyways. But we're gonna have to generate the code, and then we can actually start using it. So let's go look at that. So in here, this was, let's see, debug build. I don't know that it matters, but we'll do the null. Which one are we currently on? The E7? E7? So it's as raft.rs. Interesting. So it's not the file name that matters at all. It's what that package name is. Which would make sense. That's okay. Okay. Then we can update this to. We're just gonna name this raft. I keep hitting F1. Okay, so this keyboard is really. F1 is really close to escape. All right, let's see. This would be let's see, raft client. This is raft. It's interesting, there's the raft client and there's the raft server. Actually, you know what I kind of want to do? Let's do this, actually. Okay, so the messages are outside of the client and server. That's what I wanted to validate. So over here, we could really do, you know, this is actually like more like this. And we could in here do like a vote reply and vote request. Vote request. Let's see. Yeah. I know I have unused imports. I'm just playing around. I get it. I get it. Okay. Let's just do let's implement the raft server. Okay, so now we can actually think about writing some of the code. to talk to each other. Do we want to do a ping? Let's start with a ping. Let's start with a ping. Right there. That's actually pretty smart. That's pretty smart because there is an appendant. There is like a adding of entry that the leader will do. That's pretty smart. All right. What are we doing here though? We're gonna do a ping for ourselves. Ping request, ping reply, beautiful. We're just gonna leave those as message and message. Don't really care. This error is kind of annoying. I don't have Vim set up to do proto buffers. Unable to hand expect exactly one compiler job. Yeah, I don't know. It's a little annoying. We'll have to see if we can't fix that at some point. All right, so what we'll do is we'll just we'll delete that. Use raft. What is this hello request? I don't have any oh, not what I meant to do. I'm sorry. I'm sorry. All right, so then we're here. Pub function. Start gRPC server. Let's see, is that what we wanted? We picked a random IP. Why are we IPv6? No, I refuse. Will this just do localhost? Maybe. We'll find out. All right, so then raft server. Raft failed to resolve. Okay, so this we're gonna have to implement the raft server, which should be fairly simple, right? So we'll look at the server. So yeah, let's do that. I don't know why I copy and pasted that. That was not that useful. Let's see. This is going to be raft server. And then what? Yeah, we're just going to do greeter, which should be part of the greeter server. So yes. Impl. What is it called? It's greeter for my greeter. Yeah, I think it's just going to be called raft. For raft server. I got to look through those imports. I don't know what it was generated as. I kind of guessed at raft. Oh, look at that. Oh, look at that. Oh, okay. Something else is editing this file. Did I already open it up? I probably did already open it up. Yeah. The trait is raft. Cool. Nice. Okay. I guessed right. So we need vote and ping. Actually, let's go back and yank that definition out. Let's paste that in there. All right. So I don't think in real raft we're going to have a ping. There is a ping. So if you go look at raft consensus, which is what we're implementing, let's speed up time a little bit so you can see. And basically this is just going to be, this is the back and forth, but this is effectively voting and ping at the same time. So right now we're just getting the system working and we're going to be able to see this. But yeah. I think, yeah, I don't know what we'll call it. We'll call it something. There, that's my only guarantee. We will call it something. Okay? We will call it something. Maybe ping, maybe not ping. What did you miss? Grumpington, you missed only that you were correct in that it was there and I was an idiot. That is the only thing you missed. We just had to do this little nice include of our raft, and now we've imported raft, and now we're implementing raft for raft server. So grand scope of thing, nothing really important. It's only very important when I was right and people were disagreeing with me. We created a few errors, but yeah, so it's actually in the target specific build directory, which is a little weird. I thought it was going to like put it with the code. I'm not sure how I feel on this. And you know, honestly, I'm not sure how I feel on this. And there's also like configuration that they do. So I'm not sure if this is one of those configuration things that we kind of skipped over. And if so, like, that's fine. In their build RS, they were doing stuff like this where like they could get an output directory and that's where they were putting their files. So I think maybe tonight I'll do a little bit of reading to see a little bit more what they're doing here. This was weird because they were putting a bin here. So I was like, I'm not going to do that. So anyways, we got some lifetime parameters. Let's see. We don't want this. Let's get it to import vote. Yeah, let's do that. There we go. All right, lifetime parameter. Okay, the lifetime parameters or bounds on method vote do not match the trait declaration. Lifetimes do not match. What do you mean? We don't have any lifetime. Do we? I think it's just getting confused with the super here. Which was from the, we copied and pasted. We copied and pasted a little. Yes, but I was thinking that maybe we could like, I agree with you. I was thinking that we could set it to our we could set it to our proto, but I'm not even sure if that's like the right thing to do. That's why I said I have to think about it. We could have set it here, I guess, in theory. But this seems, this thing right here seems very well tuned to reading it from where it is. So this is probably the best play. We got some lifetime, but I'm pretty sure this is just maybe a cleanup needed. Oh, this was garbage generation. So I think ChatGPT or Copilot generated that for us. Oh, that was just garbage. We have message. That's the only field we have here. So I actually think the term, actually, interestingly enough, this stuff here, right here, this is actually raft stuff, which is actually kind of cool and interesting. The term and the vote granted is actually part of voting in raft. So when we get further into it, we're going to touch about the terms and how they do that. So you can look at this here and see vote granted is actually a thing here. So yeah, so we can actually how do we get out? Okay, so you can see here about the vote granted. They'll be different. So interesting. It was trying to do rafty things, which is kind of interesting that it derived that from the fact that we called it raft. Like nothing in here is raft other than its name. I'm impressed. Now it does a bunch of garbage too. If you guys didn't join me for my AI games, it does a bunch of garbage too. And so the other thing that I was noticing here is it did this candidate ID, which that's what you're voting on is the candidate ID, which is, again, garbage here because this doesn't have a candidate ID. So we're just going to do hello. Lame, but easy. Did I miss? I did. All right, there we go. Grampington, you're right. Yep. Current term. Yep. You're absolutely right, Grampington. It's pretty cool. Like some of the problem though with it is like, while that's amazing that it tied those things together, which makes sense, it also is a little frustrating because a lot of the times it's wrong with what you're wanting at the time. Okay. Okay, so this is... Let's see. All right, so it's still angry with the lifetimes. Now, part of me thinks that... Let's go see their example. I think I need to put this on there, for one. Because I don't know, in Rust 2021, I don't think async is supported yet. I'm not 100% sure. I know that support, yeah, okay, that was the issue, was these are asynchronous, yeah. If you guys don't know, this was implementing raft, and raft is this raft is a trait, and this trait has asynchronous functions because it's gRPC, and async functions in a trait aren't supported until I don't know which version. I think it's the newest version. I think I'm on a version that supports it, maybe, or it's the next version. Maybe it's the next version. I need to look at that. Yes, Grumpington, you are correct. All right, so we created a new raft server. We implemented it. Cool. Now, this is all wrong. I think we can do just raft server here. I think default should be fine. We said that it supported default. Let's see how they implement it. Yeah, they just did default. Oh, why did we do this? That's a what the garbage? Oh, okay, well, that should be better. Okay, better. They are doing the IPv6 stuff here for localhost. You know what? We'll do the IPv6 for localhost. We all are getting on the IPv6 train, right? Oh, that's actually a really good point, Grumpington. Thanks for calling that out. Even if I was on it, because the implementation here has the async trait, you are correct. Since it's pulling in the async trait from up here, I'm assuming it pulls it in. I was gonna find it. But anyways, you are correct. It should. Let's rename this to raft server impl. That's so dumb. Naming is hard when you're talking about gRPC. Because the gRPC is what I would... I'll think about this because this is good. A little dumb. But it's okay for right now. A little bit dumb. Where are they pulling server from? Oh, that's a tonic thing. Okay. Makes sense. Not a me thing. You know, I also need to do, I want write to run format, Rust format. I need to set that up. I haven't actually we've been doing Go for Eddington, and I haven't set up Rust for Vim yet. So I'm just learning Vim. So if you see something I should be using a key combo, let me know. I'll use that key combo. I'll try to learn it. I've been learning, but I haven't set it up for Rust yet. So that's actually something we need to do. I hope in the future they'll replace the... Yeah, I don't know about that. I don't know. I mean, I'm glad that we have support for async functions in traits. Yeah. Right, Grumpington. I'm running a gRPC server that contains the raft server service that uses the implementation in your... Right. This looks... this looks like a gross naming, but... It is what it is. Can we derive clone from this? Requires to be bound. What is this? Okay, so I've screwed up. What did they do that I didn't do? They only drive default. Oh, okay. I think I see here. So, greeter server new. Greeter. They're making a new greeter here called greeter. Oh my gosh. This is... I need to do... okay, this is... I'm going to have to think about naming here. Because basically what I need to do here now is a raft server new on my raft implementation. Oh gosh. Okay, so anyways. I gotta think about this. Oops. That's fine. Okay. Now, we don't need to unwrap. Well, we do kind of. We'll leave it as unwrapped right now. It's fine. Right, you need the generated service. This is where, like, the naming gets a little bit of a mess. 1 second. Let me go ask somebody to close my door since they're yelling up there. I'll be right back. All right. Okay. Yep. So the naming is really gross here because there's so many things called raft. I'm gonna have to think tonight about the naming here because I absolutely hate it. I absolutely hate it. It's Latho90. Thanks for the follow. You're an absolute legend, and you know what? You're a legend without a story. And do you know why it's important to realize that you're a legend without a story is because every person who follows gets a custom story. But today, of all days, your custom story is not getting generated. It's a fantastic story, and we just don't know it. So you know what I'm going to recommend, Latho, is that you join tomorrow, because I'll make sure that the null cloud is back up and running and kicking, and you'll get that auto-generated. So stay followed for today, but you can unfollow and follow again and get your custom story tomorrow. It will be saved in a database. It will eventually be visible on my website. And yeah. So follow tomorrow, again, because you're a legend and you deserve a custom story, but my servers are right here. The null cloud is self-hosted on these bad boys. These are just framework laptop motherboards. And obviously I'm holding it and it's not plugged in. It's not pure wireless yet. Hey.
Live stream?
I am.
How you doing?
I'm good. You joining me?
You want to join your live stream?
You absolutely can. This is my brother. You're gonna have to bend down a little bit.
I don't see him.
There you go.
Hey, I don't see. Is his name Ken?
Ken,
Where's he at?
where's who at?
Oh, you're
I'm streaming.
Oh, you're the streamer. Okay.
Yeah.
Nice. So you're teaching?
Right now I'm getting my butt kicked by naming things. That's what I'm doing. Yeah.
Okay.
Yeah.
You're playing like a challenge or something?
No, no, I'm just trying to write some code and the code isn't liking it. I'm not a code whisperer.
Is it complicated?
No, I haven't tried to do anything complicated. Complicated's tomorrow and the next day. Today was me trying to do relatively rudimentary things like set up a gRPC server. And yeah.
What's complicated for me?
Yeah. I'll be up in a bit.
All right.
Good to see you. It's his birthday today. Thought they were supposed to. Yeah, you guys are a little bit early. Usually you guys show up late.
I'm not here yet.
I was gonna say usually when we say 4, it's like 4:30 or 5.
Let's see your
Yeah, I was gonna say 4:30 or 5. No, he's Grampington. He's not. Unfortunately, he's not. Weeby Wizard. Hey, good. It's good to see you, Weeby Wizard. Grampington. Nighthound. Awesome to see you all. Latho, like I was saying, you need to try tomorrow because you're a legend. You just didn't get your legendary message. Jensen. ML. What's up? Everyone's joining. Everybody thinks that I'm doing Raft, the game. But joke's on you. Joke's on you. It's not Raft, the game. Oh, it's not Raft, the game. It's Raft. It's Raft, the not game. Raft, the work, the consensus protocol. At least he doesn't have to suffer. I feel like us developers want other people to develop so that they know our pain. You know, like they always look at us and they're like, oh, you sit at a desk and like write some words and you're like, oh, you don't know my pain. And we like to share that. Nighthound, if you're wanting to look at a swim implementation, I already have that for you. Swim is not consensus, by the way. Just to be clear, it's a clustering protocol. It's different. It's different. It's not trying to come up with. Anyways, if you look through Legion and look through some of its source, you're going to look at cluster management is actually if you go through this, it uses Swim, a custom version of Swim. So it's a very simple implementation, but yeah. Check it out if you're wanting to. If you actually want to see all of it, it's mostly in common, I believe. This was like 2 years ago that I did it. We will do Swim next year sometime. It's not pure Swim because pure Swim kind of sucks. But a version of Swim will do for cluster management. So yeah, you got a framework there for it. But yeah, Swim is cool. It's a cool clustering mechanism. Actually, HashiCorp did a really cool write-up on Swim as a clustering algorithm. So the other thing that I'm noticing here is there's also the client. The naming of this, I think I need to rework the naming of this. I feel like this is really rough. Like, even I don't really know. Like, the word raft is used too many times. Let's get rid of the client. The word raft is used too many times. There's this raft server, which is the generated code for the gRPC server. There's the implementation, the raft server implementation, but that isn't the actual raft server. That's just the implementation of the functions I need to implement. There's the raft server implementation that has to implement raft. Yeah, I'm gonna have to think about this. I don't know off the top of my head. I don't know off the top of my head. Well, there's a little bit of issue with me streaming. So for all of you, I am probably going to have to get going. It's his birthday today. So we're doing a birthday dinner. I'm going to get going. But for all of you that are wondering, I'll be streaming tomorrow. We'll be doing all this week or for the next 5 days. But the other thing to know is that what was I going to say? Oh, I am getting better internet. So part of your buffering issue, I think, is partially my fault because I have really bad internet. If you notice, like, isn't always smooth. Maybe it's smooth now. Now that I say it's not smooth, it's going to be smooth on me. But anyways, part of that's my bad. And I think my internet provider. But I'm getting fiber. I'm signed up for it. It's finally coming to my house, and that should, I don't know why I have a screwdriver or why I'm holding it, but that should fix it. So I'm sorry for the bad stream as it is. There was only one provider for a while, and you know, I'm getting another provider, and I'm switching. I'm gonna get fiber, gonna get 2 gigs. Right now I'm on 10 megabytes per second up, and I'm gonna go to 2 gigabytes per second up. So if that doesn't do it, then I know that there's something else that's a problem. Well, okay. Anyways, thanks everybody for joining today. If you like, I start 12 noon Eastern time tomorrow, and I will be doing that all of next week as we learn about consensus and raft. And I hope that you guys like these. Hope you like to learn with me and my pain. And yeah, we'll be doing that all next week. So thanks everyone. I'll see you tomorrow, hopefully. And I'll think about the names and we'll update it tomorrow to be a little bit better names. I feel like there has to be a better choice. So. Hey, Weeby Wizard. I would agree with you, but I don't think it is. I actually set my network up on stream. Let me open it up for you. I have a pretty nice network because one thing that I wanted to do with my stream was we run the null cloud. And the null cloud, I wanted basically you have a direct portal into my home's network. Okay. So because of that, I wanted an enterprise level router. So I actually have an enterprise switch with quality of service. So like, I'm not going to click through everything because I don't want to leak my static IP address again, but I do have a pretty nice, network. So all things being considered, I don't think that is going to be the issue. It's pretty nice. Now, one thing that we need to do, and I don't know, would you guys like to do it? Because I'll do it in the evenings one of these days. I'm redoing the network for the null cloud. Do you guys like seeing that? Like, I'm just going to be clicking through stuff. I don't know the Ubiquity command line well enough, so I can't do it through the command line. I'll just be clicking through the UI to set up the networks 100%. I don't know if you guys like that type of stuff. Let me know if you do or not. I got the Dream Machine Special Edition. Yeah. So it looks like this. It looks like this right here. It's rack mounted. Yeah. So it's rack mounted. It's pretty cool. It's actually, yeah, it does have the PoE ports, which is really cool because the wireless upstairs is actually provided by a single cable PoE from the Dream Machine. So if you go through to the not the clients, the unified devices, this is sitting right there and it's getting the PoE directly from it. So I only had to run one cable up my wall, which was pretty awesome. Yeah. Raft, Rust in the Path of Exile. So, Grampington, you're going to enjoy when we have when the Twitch alerts are up, because let me show them to you. When we get Twitch alerts going again, which should be tomorrow, I'm hopefully gonna. Oh man, that means I have to do the networking tonight. When I get back on, I might start streaming anyways, which will be later tonight. But when we do this, the all right, so you are D&D GPT. When answering questions, you always answer with a short epic stories as a Dungeons and Dragon master in 65 words or less. So basically, and we actually edited a little bit for like so like if there's a follow event is a little different than like if you subscribe, because if you subscribe we make it a little bit more but like tell me an epic story about how you join forces with the null party, whereas if you subscribe it's about how you supported the party, and if you raided it's how you your two teams joined together. But anyways, we get some pretty epic stories, some epic D&D stories, and it's a lot of fun. Yeah. Hey, Scott B. They're kind of expensive. Yeah. So my thing was, I'll explain the null cloud later because I do have to get going. Sorry, Scott B. I am getting going. It's good to see you though. I wanted the secure double network. So basically the null cloud, which the incoming request from the internet gets dumped into, has no ability to route to my home network. And I know that there's other cheaper routers that did that, but because I was opening myself up and going to ask you guys to hit that, I wanted to make it at least as secure as I could, somewhat. It was, I want to say only $500, which I know is still super expensive, but it was going to be like $250 for a good home router anyways, that supported OpenWRT. So the channel itself is an RPG. Okay, true story. I want to make the channel itself to be some sort of game. I think that would be a lot of fun, where we have like channel points and stuff that you guys could spend. So next year for Christmas, when I do this again, where I'm streaming every single day, I want it to be something where you can spend your points to either make my life harder or easier. I'm not quite sure how it's going to work, But yes, the channel should be somewhat of a game. It's a game of suffering. That's what it is. Anyways, I got to get going. You guys have a fantastic day. Thanks for chatting, hanging out. I will see you guys tomorrow. We'll do some more raft. We'll do some more D&D. Have yourselves a fantastic rest of your day.